Okay. Below are 7 puzzles, each with a missing section. From the draggable items, select the correct equivalent option to complete each puzzle. Alright, so let's check what options do we have. What sort of a question it is. The question is basically asking us to make sure that our answer, our final answer, is numerically equivalent to what is being shown above. So I know that, for instance, if I was to divide 16 and 24, both of them by 4, I should get an answer of 4 ratio 6. Here I have 6 ratio 4, which is not going to be accepted, right? I have 24 ratio 36, which is numerically equivalent to 4 ratio 6. I have 1 ratio 3, which once again is not going to be accepted. Why is 24 ratio 36 is a viable option? Reason being is that first things first, they are both within the ratios of 4 ratio 6, and secondly, they're just larger numbers as compared to what we have initially. So our answer is going to be 24 ratio 36. So this was just an example of um, what sort of a question you might end up having. This part makes sense?
Yeah.
All right. Okay. Standard forms. 1.08 multiplied by 10 raised to the power of 4. All right. This should be numerically equivalent to one of the three options. Let's consider the first one. One, oh, okay, in fact, you know what should I do? I should write this into a number form. 1.08 can also be written as, since we have a positive 4 value as the power above 10, 1, 2, 3, 4. So basically, a decimal point should be moving 4 values towards the left, towards the right. So this becomes 10800.0. Realistically, if we were to remove the standard form notation. Now, what are the options that we have? If I was to solve this question using the same way, I would get a decimal point here and here, two values towards the right. So I would also get 10800.0 here. Alright, let's check this one out. Two values towards the right, 1, 2. 108.0, but this is not equivalent to the value that we originally need. And just like that, 108.0, two more zeros, 0, 0. We have three zeros in our final answer without a decimal point. So that's also not going to be considered. So in reality, our answer is, when we are going to drag this part, we are essentially going to drag this region. 108, 108 multiplied by 100. That's going to give us a numerically accurate value as compared to what we needed. All right. A raised to the power of 2 multiplied by a raised to the power of 7 divided by a raised to the power of 3. Now, we know that whenever we have different powers and same bases, and there is a multiplication sign in between. So we get a raised to the power of the powers being added together, and the denominator remains as it is. So a raised to the power of 2 plus 7 becomes a raised to the power of 9, and that should be divided by a raised to the power of 3. Now, since there is a division sign in between, since there is a division sign in between, I know that I can write this as the base remaining the same and the powers subtracting with each other. So this gives me a raised to the power of 6. This was a 1 mark question as well. 2a plus b minus 2 into a minus b. 2 needs to be multiplied with a. First, let's expand the bracket. We get 2a plus b minus 2a minus 2 multiplied by minus b becomes positive 2b. So let's take a terms on one side and non like b terms on the other side. 2a minus 2a, this cancels out to become 0. b plus 3b, b plus 2b becomes simply 3b. Here you go. That's going to be your answer. Alright, this is a relatively a bit difficult question. This shouldn't be too much of difficulty. Hmm. First things first, I mean, without even numerically solving it, you should know that this should be the answer because uh, a cannot be further simplified in any case. So it's not possible that we get an under root value which is without an a. Alright, but still, let's verify it. Under root 27 can also be written as under root 9 multiplied by under root of 3. Under root 9 becomes 3. And we already have a from before. So this becomes a 3a under root 3 minus a under root 3. Now considering we have the common region of under root 3 in both circumstances, we are not in an extreme need for it. So our final answer here might contain under root 3. But once again, 3a minus a needs to be solved. So 3a minus a becomes 2a. So we get 2a under root of 3. Are there any questions as of yet?
No, yeah, no.
Oh, these are relatively very easier questions. As of yet, the difficult questions haven't started. 4x squared minus 11x minus 3. Alright. Now, there could be two ways of solving this question. Either you could directly solve it, for instance, solve it using the method we always do. We take the middle term breaking. So first we multiply 4 and 3, that becomes 12, and then we find a pair of factors. So we have 12 times 1, 4 times 3, 6 times 2, and of course we need a factor that adds or subtract to give us negative 11. So we select 12 times 1. So we get 4x squared minus 12x plus 11 plus 1x minus 3, because minus 12 plus 1 becomes minus 11. We take 4x as common, and within the bracket we have x minus 3. We take plus 1 as common, and within the bracket we have x minus 3 again. So we have two brackets, x minus 3 and 4x plus 1. So we are going to select the answer as 4x plus 1. This is the first way of doing it, the numerical way, to solve the complete question. Oops, wait a second, please. Yeah, and in case if you are writing this down. Now, the second method was that you should have identified that the answer consists of 4x squared minus 11x minus 3. So automatically, the first term in our second bracket had to be a 4. So that satisfies the entire criteria. And the last term is supposed to be 3. Now, we already had 3 in the first bracket. So the second term of the second bracket had to be a positive 1. Why positive 1? Because had it been negative 3, like if let's say we would have had x minus 3 multiplied by 4x plus 4x plus 3, or 4x minus 3 as what has been given to us in this part. So automatically 3 times 3 would have become 9. right? But here we don't have 9, we have positive 3. All right. So that's how logically you can eliminate your answers. Whenever we are solving, these are examples of multiple choice questions basically, okay? So I tell my students, whenever we're solving questions of multiple choice now, always make sure to eliminate the wrong option first, because that clears things a lot. It's not easy to find the right option always, but it's easier if you do it by first eliminating the wrong option. You can get closer to the right answer. All right.
Yep.
And then we have 2x plus 1 into 5x minus 2. Pretty simple. 2x multiplied by 5x becomes 10x. 2x multiplied by negative 2 becomes negative 4x. Sorry, 10x squared, my bad, 10x squared. 1 plus 5x becomes 5x, and 1 minus 2 becomes negative. 10x squared minus 4x plus 5x becomes positive 1x minus 2. So this answer makes the most sense. 10x squared plus x minus 2. So I think this was the last part of question number 1. Yep, absolutely. All right. So tell me once you're done. So number question number 2 says the function. Okay, don't get worried whenever you see the word function f of x. Don't get worried at all. F of x is another way of writing y. Okay, f of x is another way of writing y. So you don't have to get worried looking at it.
Yep.
Calculate the maximum value of f of x. The maximum value or the minimum value is essentially the same thing. Not, not directly the same thing, but it can also be called the turning point. Do you remember our algebra class for turning point?
Yeah.
Yeah? Okay. This is the equation of the function that is being given. So let me um, expand this bracket. So I get minus x squared plus 5. If I was to expand the bracket, minus x multiplied by x becomes minus x squared, and minus x multiplied by minus 5 becomes positive 5 x. All right. So now it says calculate the maximum value, the turning point coordinates. And the turning point coordinates are, of course, supposed to be in the form of x comma y. All right. So we applied the formula as x equals minus b divided by 2a. I hope you remember this formula. That is the formula that is used to find the turning point of a curve. So the value of a is negative 1 and the value of b is positive 5. So we get minus 5 over 2 multiplied by negative 1. So we get minus 5 over negative 2. 5 over 2 becomes 2.5. So the x coordinate is going to be 2.5 of the turning point. What about the y coordinate? In order to find the y coordinate, we have to substitute the value of 2.5 into the equation. And this is the equation, minus x multiplied by x minus 5. So we would get y equals, because it's minus x, so we'll introduce a minus sign already before it. Minus 2.5 multiplied by 2.5 minus 5. Can you please go to your calculator and solve this value and tell me what answer do you get?
I got 6.25.
6.25, very well done. It should have been a positive value. Why? Because the turning point from the y-axis perspective, it is definitely a positive value. And look, even from the x-axis perspective, have a look. Isn't this turning on the exact point between 2 and 3? Almost. So it looks like our answer has been verified. If a graph has been given to you, your concept should be strong enough to be able to verify that answer. So your coordinates are 2.5, comma 6.25. Uh, the function f of x is transformed to g of x by a translation of L units towards the right. Okay, this is right now, this is not something that you have learned, transformation. So I'm not going to go into too much detail, but the thing is that the entire question is really amazing. And um, okay, what I am going to do is, hmm, the thing is that this question is in itself is really good, but you haven't solved the rest of the parts as of yet. Transformation is not something you have done. It's basically in grade 10. Okay, I'll just write down the answers so you don't have to understand this part. The function f of x is transformed to g of x by translation of L units towards the right. Press next to illustrate below. So, I mean, that was quite fairly evident. Where was it? Where is the transform graph of g of x? So, basically, the answer was of 2 units. All right. And when the answer was of 2 units, it was intersecting the x-axis at these 2 points. This was essentially the graph. So it was intersecting at x equals to 2 and intersecting at x equals to 7. Now, my question is, and now look, even you can see that there is a positive movement towards towards the right by two values, right? Because from here we had 0 and here we have 2. From where we have 5 and here we had 7, right? So even you can see the difference even though you haven't studied the topic. Now I want you to solve this question. Hence, determine the equation for g of x. This is the line of g of x, and you are supposed to determine the equation. What do I mean by determining the equation? It means to essentially factorize it and tell me how would you solve this equation. Now in front of us, we can see that this line is intersecting the x-axis at 2 points, which means the value of x should be either 2 or the value of x should be either 7. Do we agree up till here?
Yep.
Okay. Now, if this is the answer, if this is the answer, so I can also write this as x minus 2 multiplied by x minus 7, right?
Yep.
Yeah? So that's how we're essentially supposed to solve this question. That was supposed to be our method. All right. So
Yep.
the equation for g of x can be written as in this way basically. And of course, because it is an upward facing parabola, we were supposed to introduce a minus sign from before already. We have to be very careful in this regard, because otherwise if we would have just left it as it is, so x minus 2 into x minus 7 looks like this. This is the downward facing parabola. This part is called the minimum point or the turning point as well. Once again, okay, I'll just generally tell the answers. I just don't want to leave it as it is. So basically, when reflection takes place, it says the function g of x is transformed to h of x by reflection in the x-axis. Write down the equation for h of x. So when a reflection takes place, the negative sign is removed. All right. So I really doubt your teachers would give you this question at right now. And then it says write down the minimum value of h of x. So we have the equation that looks like this: x minus 2 multiplied by x minus 7. If we were to solve it, we would get x squared minus 7x minus 9x. Oh, sorry, wait. Minus 7x minus 2x. This is a part you can solve. Minus 2x minus 2 multiplied by minus 7 becomes positive 14. So we get x squared minus 9x plus 14. It says find the minimum point of this curve. So we know x equals minus b divided by 2a. Alright. So minus 9 over 2 times 1. But we already have a minus from before and a minus additionally. So this becomes positive 9. So this becomes 9 over 2, which essentially becomes 4.5. Now this is the x coordinate 4.5. We have to find the value of y. All right, y coordinate as well. So what are we going to do? We have the equation. We substitute 4.5 in this equation. We get 4.5 whole squared minus 9 multiplied by 4.5 plus 14. And this is going to give us the value of y. So if you were to solve this part, you would get 4.5 squared minus 9 multiplied by 4.5 plus 14. I get an answer of y equals to minus 6.25. All right. So the minimum values are basically turning points, which is 4.5 comma minus 6.25. Once again, parts of it are the ones that you're going to be able to solve. Um, you don't have to read all of this. It saves you a lot of time, I promise you. People with blood type O negative are known as universal donors. They can donate their blood to patients with any blood type. Show that the probability that a randomly selected person has a blood type O minus is 0.1. All right. So O in itself is supposed to be, what percentage is O supposed to be? We have 100 equals, let's consider x plus 44 plus 11 plus 5. 100 equals x plus 44 plus 11 is 55. 55 plus 5 is 60. X equals 100 minus 60 and x equals 40. So basically, the O type is present with 40% of people. Now, 25% of those 40% are O negatives, as we can see here. So, logically speaking, if we multiply 25%, which is 25 over 100, multiplied by 40 over 100, because a percentage of that percentage have a specific blood type. So we get 25 times 4 is 100, and 25 times 40 is 1000. So, and this becomes 10,000. So, three zeros get cancelled, three zeros get cancelled. We get 1 over 10, and you get essentially 0.1. Does that make sense?
Yeah.
All right. 30 people donate blood one morning. Determine the exact number of people that have blood type O minus. So the probability of having O minus is 0.1. 30 people have donated blood. So this becomes 30 multiplied by 0.1. As simple as that. If we were to solve this question, we would get an answer of 30 multiplied by 0.1. This becomes simply 3. Because it's 10%, right? 10% people have O minus, 30% have donated the blood. So, of course, only 3%, only 3 people are going to have that blood type. Let's move forward. 2 of the 30 donors are selected at random. Write down the missing values in the tree diagram. Okay. Now look, in the first donor example, we have 3 people with a blood type of O negative. So if 3 people had the blood type of O negative, how many people would have had an O type, which is a blood type which is not O negative? Simply 30 minus 3 over 30, right? So that becomes 27 over 30, right? Does this make sense?
Yeah.
Okay. Now, let's say you have a category of those 3 people again, and there is a second donor taking place. So now I know that if there is a second donor taking place, of course, now I will be left with 2 people if another O negative donor has been selected out of the rest of 29. But if in another scenario, a person that has been taken out as a donor did not belong to the O minus category, with the condition that the first person had belonged to it, if the second person does not belong to it. So the denominator is supposed to change. 29, denominator removed. One person has been changed. But the numerator remains as it is. Still, there are still 27 people out of 29 that don't belong to the O minus category. Okay? This is the tricky part. I hope you understand this region. And
Yeah.
just like that. If let's say in the first case scenario, a group of individuals was selected from the not O minus categories. They were selected from the not O minus category. So I know, of course, the denominator is supposed to change without a shadow of doubt. But what about the numerator? If in the first case there was not O minus, so in the second case there will still be 3 people left. But if another person was removed from here, not O minus category again, so we are left with 26 people now. This is how we are supposed to solve questions of donors and basically probability. All right. I hope this makes sense. Write it down so that we
Yep.
can move forward. So next, what do we have? Find the probability that only one of the two donors has blood type O minus. only one of the two. There are two ways in which it can be done. One of the two can either be in this way, or it can be this way, right? So I can write this as 3 over 30 multiplied by 27 over 29. This is the first probability, P1. 3 times 27 is 81, 30 times 29 is 870. Then the second probability is 27 over 30 multiplied by 3 over 29. So that becomes 81 over 870 yet again. If we were to add both of them together, 81 over 870 plus 81 over 870. So why are we adding them both together after multiplying? Because we're supposed to find the total probability. Alright. So this becomes 162 divided by 870. And if we were to divide this by let's say 3, we would get an answer of 54 over 290. And this is going to be our final answer. I hope this part makes sense.
Yep.
Great. Um, Wait a second. So at least let's solve question number 6 for now. Many efforts have been made through the years to put into action. Okay, once again, I tell most of my students if there is no numericals given in it, um, you don't have to um, once again read each and everything. Annual exposure to particulate matter across Europe in 1990. So what we are essentially calculating here is we have a number of countries, and we are seeing that when particulate matter is released due to carbon monoxide or whatever the problem is, um, there is some exposure that takes place, and that is calculated by the formula microgram over meter cube. Can you tell me? It's like a physics question. Can you tell me what sort of derived unit are we calculating here? So, in order to solve this question, annual exposure to particulate matter across Europe in 1990 has been given to us. How to solve the question entirely? What does the question even say? To visualize the level of exposure across Europe in 1990, use a table to construct a histogram. Okay, use a table to construct a histogram. Okay, this is the table. Let me bring the histogram down, the table down. Screenshot has been taken. Uh, So, number of European countries, as we know, there are three European countries that have been exposed to 0 to 10 microgram per cubic meter volume of exposure. So, 3 is roughly going to be here in between. You don't have to write this down, you just have to see how am I working. And I can shade it if I want. If I don't, it's fine as well. Then 17 countries were from the range of 10 to 20. So 17 lies somewhere here, right? 6 countries lie from the range of 20 to 30. Then 9 countries lie within the range of 30 to 40. 9 is between 8 and 10 here. 3 countries lie within the range of 40 to 50. And 1 country lies within the range of 50 to 60. So 1 is between 0 and 2, like this. Alright, I hope this makes sense.
Yep.
So that's how we're supposed to calculate and in fact construct this histogram. In comparison with your histogram in part A, state one difference between the annual exposure to particulate matter in 1990 and 2016. So whenever you have this question, you have to not just quantitatively, rather qualitatively describe it as well. Describe the difference as well. How do you do that? First things first, you know, you can write this as, for instance, um, highest in 1990. You can talk about the highest value. Highest in 1990 was 17 microgram per meter cube, whereas highest in 2026, no, wait, highest 2026 2016, okay, 2016 was 24. Yeah, exactly 24 microgram per meter cube. It's not important for you to mention the value, I'm just mentioning it. So that is one big difference that we can visibly see in front of us. Use the histogram for 2016, this one, show that an estimate for the mean of E in 2016 is 15.3 to the nearest one decimal place. Now, when we are using a histogram for this example, the first thing that we have to do is that we have to find the mean point of each value. We have to find the mean point of each value. So between 0 to 10, the mean is 5. Between 10 to 20, the mean is 15. Between 20 to 30, the mean is 25. And between 30 to 40, the mean is 35. 5, 15, 25, 35. These are the general means. Now, Once we know what the means are essentially, okay, once we know what the means are, let's calculate and multiply it with the frequency. So there were 8 countries which had a mean or an average of 5. There were 24 countries that had a mean of 15. There were 5 countries that had a mean of 25, and there were 2 countries that had a mean of 35. And what are we supposed to do? We are supposed to divide this entire value by 39. Why? Because 39 is the total frequency. What do I mean? There is a total of 39 countries being calculated about in Europe when this happened. How do I know that? Look, 2, 4, 8, and 24. In fact, no, this is not 4, this is 5. So 24 plus 8 plus 5 plus 2. 32 plus 7, which becomes 39. So this entire value, in order to find the arithmetic mean, is going to be divided by 39. Then you get an answer of 595 divided by 39, and that becomes 15.25. That can be rounded off to simply 15.3. Then we have part D. The data from 1990 to 2016 can be modeled by a line of best fit as shown in graph 1. Okay, great. E equals to AN plus B. Now, this is pretty difficult to understand, but not too difficult as well. Can we say that this line is also being represented in the form of y equals to mx plus c, the equation of a line? We can say that. Alright, so in order to solve for this question, if you were to compare the values with each other, I know that B is going to be somewhere around here, years after 1990. Alright, years after 1990. So if I was to use the graph above and see that after 1 year, in fact, wait a second, wait a second. So yeah, first things first, let me find the gradient of this line. How to find the gradient? The gradient can be found by the formula y2 minus y1 over x2 minus x1. You have studied this in class, right? In physics, in maths,
Yeah.
whatever, right? Okay. So let's take this coordinate 10 comma 16.5 and this coordinate which is 5 comma 17 as an example. We have y2, x2, x1, y1. So if we were to apply this formula, we get 16.5 minus 17 over 10 minus 5. So 16.5 minus 17. This becomes minus 0.5 and 10 minus 5 becomes 5. Or is it actually 16.5 and it's just 16 as it is? It's just 16 as it is, sorry. My bad. So it is 10 comma 16. So 16.5 is not going to be written, 16 is going to be written. So we get 16 minus 17, which becomes minus 1. And yes, if we were to look at the marking scheme, we have the gradient as minus 1 over 5. So the value of A, which is M, is minus 1 over 5. N is the number of years after 1990. And E is the exposure to particulate matter. So I can say, in order to find the value of B, I have the values of E, A. How many values do I have? I have to, the equation is given as E equals A n plus B. I have to find the value of B. So I know I can write this as E minus A n equals to B. So um, the value of E is going to be in this case 15. The value of A is going to be minus 1 over 5. And the value of B is going to be positive 20 because N is going to be positive 20 and E is going to be positive 15 as we speak. So we have to solve this question. 15 plus 0.5 plus 0.2 multiplied by 20, we get an answer of somewhere around 90. And yeah, minus 0.2 multiplied by 20. We get an answer of B equals 19 roughly. So we have the equation y equals negative 1 over 5 x, or in fact no, I should write it in the form E equals negative 1 over 5 n plus 90. Alright, that's how we find the values of A and B. Alright, now up from these questions onwards, you don't need to have a concept. You have to have the identification of what is present inside the graph, what is the um, information given and stuff like that. You are a statistical advisor on a government panel that wants to reduce annual exposure to particulate matter in Europe to a level below 13 microgram per cubic meter by 2030. Analyze the two models to make a prediction of annual exposure to particulate matter in 2030. In your answer, you should identify a factor from the data to be considered while making your prediction. Okay. A factor that needs to be considered. Hmm. What can be a positive factor or a factor that can be considered in this? Look, one factor that we can visibly see in front of us is that the value of E, which is actually the annual exposure of um, emissions, that is being reduced. If we look at the graph, right, the graph is moving downwards. So while I'm making my prediction, I know that the exposure is decreasing. Okay? So I can say, in order to identify a factor, I have considered that E is decreasing. You predict the level of annual exposure to particulate matter in 2030 using models from both graphs. So this is the first graph that we have, and years after 1990, this is basically the year 2020, and this is the year 2020 as well. Now, without a shadow of doubt, we can see that across Europe, there is definitely a decrease, and it is going to continue to decrease because it's a straight line going downwards. So, for instance, if we were supposed to, let's say, if you was moving down further, this is 2020, and by here, let's say we might have 2030. So, automatically, I know one thing, and that is that the graph is going to go further down across Europe as we speak. But in this another type of inequation where there is an exponential equation being used, here comes the problem. The problem is that the graph is eventually becoming stagnant. Here, look, the graph was relatively steep, less steep, less steep, less steep, further steep, and it carries on, carries on. And there is a high possibility that by 2030 the line becomes totally straight. So, what can we talk about? The prediction. Predict the level of annual exposure using both graphs. So, I can say if linear model is used, E is going to decrease substantially, but if exponential model is used, E remains stagnant. Does this make sense?
What?
Okay, great. I think today we might do the sequence question in today's class because we have enough time. Comment on the accuracy of your predictions. So, a comment from my case would be exponential model is more realistic. As you know, I can say that the environmental reduction, it tends to increase, or no, not increase, it tends to remain same rather than decrease infinitely. Because look, realistically speaking, it's not possible that we remove all types of pollutions, right? So um, the thing is that there will always be some sort of pollution. And even if you look at the SDG, Sustainable Development Goals, they always talk about reduced carbon emissions. They don't talk about removing carbon emissions because that's not possible realistically. But we can reduce it. So I can say, in matters of commenting on the accuracy and advising the government, I can talk about the idea that exponential model is realistic as environmental emissions do reduce to stagnant position rather than being completely eliminated. All right,
Yep.
that's how I know. So the good part about this 10-mark question is 10 mark, yeah, 10 mark. You don't need to have a lot of background knowledge to solve, like mathematical knowledge. You have to be logical to see, be well versed with the current affairs to solve such questions. Okay, write it down so that we can solve the sequences question.
Right.
So let's solve question number 4 right now. So a cylindrical pool is being used to fill some amount of water. All right. In order to solve a question like this, let's first read question number 4, part A. It says, to avoid overflow, the pool is filled with 90% with water to 90% capacity. Show that 90% of the capacity is essentially 58.8. All right. So I know that we are talking essentially about the volume. So the formula for the volume of a cylinder is given by V equals pi r square h, right? So in case to find the volume, I know that pi remains as it is. R square, r is basically the radius, which is 4 square. Then the height is 1.3. So this becomes pi multiplied by 16 multiplied by 1.3. Pi multiplied by 16 multiplied by 1.3. This gives me an answer of 65.35. Now it says this is the total volume. All right. It says in order to avoid overflowing, 10% of it should be left. So if we were to find 10% of this value of 65.345, we get the answer 6.53. Let's subtract this from 65.345. If we do it, we get an answer of exactly 58.8. Hence, our answer has been proved. Next part says a pump is used to remove water from the pool. The pump removes the water at a rate of 11,200 liters per hour. All right. Find the time it takes for the pump to remove 58.8. All right. So I know that 1 meter cube is 1000 liters. So 11,200 liters is going to be x meter cube, where we have 1000 liter being 1 meter cube. So we simply have to cross multiply. This is a ratios question. 11,000 divided by 1,000 equals x. So we get an answer of 11.2 meter cube, and that is the amount per hour. Now, when this is the amount per hour, I know that I should simply divide 58.8 meter cube with the amount per hour. And if I was to solve it, I get 58.8 divided by 11.2. That gives me the answer of 5.25. But that's not 5.25, that's 5.25 hours, but that's not 5 hours and 25 minutes. That's essentially 5 hours and 15 minutes. Then we have question number 4, part C. A cylindrical pool cover is placed over the pool. The pool has a radius of 4 meters and a depth of 0.3 meters. Find the outer surface area of the pool to the nearest square meter. Okay. Now, in order to find the outer surface area, hmm, outer surface area can be found by two ways. The formula that we usually use, and that is going to be given in exam, is pi r square plus pi r h. All right. In fact, 2 pi r h. That's the formula that's used in case of a cylinder when a circle has also been given. So pi multiplied by r square, which is 4 square, plus 2 pi multiplied by 4 into 0.3. So if we were to solve it, we get 16 pi plus 4 multiplied by 0.3 multiplied by 2 pi. That becomes 7.54. And if we were to add this value to 16 pi, we get an answer of 57.8. And it says to the nearest square meter, we will get 58. Material for the pool costs $3.4 per square meter. Determine the cost. So we had 58 meters, and per square meter is 3.4. So if we were to multiply this value, we would get an answer of 196.52. And in just 7 minutes, we're done with question number 4. The video explains the use of sleeves for paper cups. All right, you don't have to look at the video in most cases. The sleeves form parts of a sector of circulation. All right, this is a sector-based question. So there are various stages. Let's check it out. All right. Show that the value of angle y is 70 degrees to the nearest degree. This value is 70 degrees. So let's consider this entire triangle. Or let's consider this small triangle, only this one. That small triangle has a hypotenuse value as 5.7, and the base value is going to be 12.55 minus 10.6. And that becomes 1.95. So we have the hypotenuse, we have the base. Which trigonometric identity links base and hypotenuse is the cosine. So cosine of x equals 1.95 over 5.7. So cosine inverse gets you the answer of 1.95 divided by 5.7, and that becomes um, 69.99, which is exactly or roughly 70 degrees. Hence, determine the value of angle x. Look, if this is 70 degrees and this is 90 degrees, so this is supposed to be 20 degrees. And the entire angle is supposed to be 20 degrees plus 20 degrees, which is roughly going to be 40 degrees. So here you go, 40 degrees would be your answer. 5 part C. Calculate the value of V. V is supposed to be this length. So, um, in order to solve for the value of V, I have the angles present with me. This angle is 20 and this length is 10.6. This length is V. This is supposed to be the hypotenuse. This is supposed to be, wait a second. Yeah, this is supposed to be the base and this is supposed to be the perpendicular. Which trigonometric identity links both of them together? So yes, it's definitely the sine. So sine of 20 equals perpendicular, which is 10.6 over h. H equals 10.6 over sine of 20. If we were to solve it, we would get an answer of 30.99, and we can round it off to simply 31.0. Then it says find the area of the sleeve, this one. So this is some sort of a sector area type of a question, part D. Hmm. I think this is what they're talking about. How many other parts have we got left? Just one more part after it. Okay. Area of the sleeve. Now, in order to find the area of the sleeve, I know that the entire length, this length V is what we calculated was roughly 31. Let's find the area of this entire region. So that becomes pi multiplied by 36.7 squared. But once again, this is just a sector of it. So that becomes basically 40 over 360 multiplied by pi multiplied by 36.7 squared. So I can write this as 40 over 360 multiplied by pi multiplied by 36.7 whole squared on my calculator, and I get an answer of 470. But I have to subtract it from this value, this region. So I'll subtract this one, minus 40 over 360 multiplied by pi multiplied by 31 squared. So